From the steep folds of the Zagros Mountains, the Qareh Aghaj River begins its journey. These mountains are composed of ancient limestones and sandstones uplifted by tectonic forces. Seasonal snowmelt and rainfall from these highlands provide the primary source of water for the river's headwaters. The Qareh Aghaj River stretches for approximately 700 kilometers, making it one of the most significant rivers in Fars Province. In narrow, mountainous reaches, the river channel is about 20 meters wide, but as it enters the broader plains, it expands up to 400 meters across. At the Qareh measurement station, the long-term average discharge is about 18 cubic meters per second, with dry season flow as low as 3.5 cubic meters per second, and typical seasonal peaks around 43 cubic meters per second. In extreme flood conditions, instantaneous measurements have exceeded 6,000 cubic meters per second, reflecting the rapid runoff response of the basin. As the river descends into agricultural valleys, the surrounding plains near Qareh are generally at elevations around 1,510 meters above sea level. Annual precipitation in these plains averages about 387 millimeters, with intense temperature swings, summers exceeding 42 degrees Celsius, and winters dropping to around -5 degrees Celsius, driving strong seasonal variation in river flow. Upstream, steep gradients and coarse bed material promote active transport of gravel and sand. Downstream, the slope decreases and the river forms braided channels. The sediment load originates largely from weathered carbonate rocks of the Zagros Fold Belt, which contribute to both suspended sediments and bed load during high flows. In this reach, the river is no longer confined to a steep mountain trench. The reduction in longitudinal slope causes a measurable decline in flow velocity and stream power. This hydraulic adjustment initiates lateral channel migration, where erosion shifts from vertical incision to bank undercutting and point bar development. Such transitions are typical of rivers draining the folded terrains of the Zagros Mountains, where gradients change abruptly over short distances. Here, the river begins constructing its own alluvial corridor, a self-formed pathway shaped by sediment deposition rather than bedrock control. Midway along the course, the Salman Farsi Dam serves as a major hydraulic structure on the Qareh Aghaj River. This concrete arch dam can store up to 1.4 billion cubic meters of water in its reservoir, which spans about 4,850 hectares. The dam supports irrigation and drinking water supplies, particularly during drier years, helping to regulate seasonal variability in flow. Geologically, the dam site rests on folded Qareh limestone formations, which influence reservoir seepage and storage behavior, a critical factor in reservoir design and hydrogeology. Downstream hydraulic behavior is strongly influenced by upstream regulation associated with Salman Farsi Dam. Even when not directly visible, large reservoirs modify hydrographs by attenuating flood peaks, delaying sediment pulses, and redistributing seasonal discharge. This results in what engineers describe as a regulated flow regime, where natural variability is partially replaced by managed release patterns. Biological assessments of water quality show that mid to lower sections of the river, especially near agricultural lands, can experience moderate to severe pollution levels, largely due to runoff from cultivated fields and mining activities. At this stage, the river interacts intensively with its floodplain. Surface flow exchanges water with shallow groundwater systems, creating a dynamic hyperheic zone beneath the channel bed. These subsurface flows act as natural biochemical filters, moderating nutrient loads and influencing dissolved oxygen concentrations. Such regulation alters sediment competence. Coarser particles settle upstream, while finer silts continue downstream, changing channel texture and bank stability over time. However, where agricultural return flows enter the system, suspended sediments and dissolved minerals may increase turbidity during high discharge periods. This interaction illustrates the dual nature of semi-arid rivers. They are simultaneously conveyors of life-supporting water and carriers of basin-derived materials. During winter and early spring, snowmelt and storm rainfall elevate river stages and increase turbidity. In contrast, summer flows decline sharply as higher temperatures drive increased evaporation and reduced base flow in this semi-arid environment. Shallower depths permit faster thermal exchange, producing daily fluctuations that can exceed several degrees Celsius between morning and afternoon. Such thermal sensitivity affects viscosity, which in turn subtly modifies flow resistance and sediment transport capacity. As the river approaches the lowlands, the channel gradient decreases and flow velocities reduce. This encourages overbank deposition of silt and finer sediments, building broad fertile floodplains that support agriculture and groundwater recharge. Eventually, water and sediment from the Qareh Aghaj River join the larger Mont River system, which discharges into the Persian Gulf, completing a classic mountain-to-coast hydrological continuum. As the river advances across the plains of Fars province, its character becomes increasingly that of a mature, low-gradient system. The channel widens, meanders lengthen, and hydraulic energy dissipates across expansive overbank zones during seasonal floods. These floods do not merely convey water. They recharge aquifers, rebuild soils, and sustain riparian vegetation adapted to episodic inundation. Ultimately, the river contributes its flow to the Mont River basin, which continues southward until reaching the Persian Gulf. By the time the water approaches the coast, it carries the integrated signature of the entire watershed: tectonic uplift, climatic forcing, erosion, transport, regulation, and deposition. A complete fluvial system expressed from mountain source to marine sink. Here, the river has lost nearly all of its gravitational driving force. Flow energy is gradually dissipated through friction, dispersion, and channel widening. Satellite imagery from space reveals the full watershed, from steep erosive headwaters in the Zagros Mountains, through broad alluvial plains, to the coastal margin. This aerial view encapsulates the interplay of tectonics, climate, geology, sediment transport, and human infrastructure that define the character of the Qareh Aghaj River system. This river is not only a flow of water, it is an active geological process, continuously reshaping landscape, infrastructure, and ecology from the Zagros Mountains to the sea.